part 2 of Unit 1. We're going to call this 1B1 and 1B2. 1B1, we're pretty much going reviewing our parent functions again in class, but we're doing minor translations, right, left, a little bit of compression, stretching, things like that, one at a time. But here in 1B2, which is what the focus of this lesson is we're going to take all those functions and start doing them all together. And again, a lot of this is a review from your previous courses. And hopefully you do have those parent functions down, because otherwise it's going to start getting really bumpy from here on out. So what we have is a general transformation rule where we have plus or minus a times f of plus or minus b, x plus or minus h, parentheses plus or minus k. And all these do something distinct to the graph. So let's go ahead and run through these real quick. I'll give this to you as a handout in class. We're going to have vertical stretchings and shrinkings. This is going to affect the y-coordinate. So this is y-coordinate stuff right here. Okay? So when a is greater than 1, it's going to stretch it vertically. When it is less than 1, it's going to shrink it or compress it vertically. And that's going to be impacting the y-coordinate. So if this was 3f, you're going to multiply all your y-coordinates by 3, so on. And then the next thing we want to look at is this plus or minus. This is not the value of a. A is either going to be greater than 1 or between 0 and 1. If it's equal to 1, there's no impact. It remains the same. There's no dilation whatsoever. All right. So we're going to have the -1 distinct from the a. And that's going to be a negation. It's going to reflect across the x-axis. Then let's go ahead and take a look at what's going on with b. But importantly, before we talk about b, we must recognize that there's going to be a leading coefficient of 1 in front of that x. So we're going to factor anything out such that we get a 1 right here. It's probably going to be the very first thing you're going to check in all these functions. And then this b is going to be more horizontal component. This is going to affect the x-coordinate by whatever factor. But this is a little counterintuitive. When b is greater than 1, you're going to shrink the graph horizontally. And when it's greater than 1, less than 1, it's going to be a stretch. Now again, b is not positive or negative. We can have a -1 or a +1 in front of that, which is going to do the reflection part across the y-axis. Okay, we're just taking that x-coordinate and reflecting across the y-coordinate. Let's take a look at this basic quadratic right here. And remember, your parent function in your quadratic is y is equal to x squared. And so when we do this, we're just going to impact what's going on. Like for instance, we do have a leading coefficient of 1 here. And so what we have is an impact on the y-coordinate of a stretching of a factor of 3, and we're going to reflect it across the x-axis. Then we're going to have a translation of 5 right and 2 up. And we're going to write these things in a generic function manner. That way we can apply this in a general sense. Let's get on to some more specifics. I got a few important tidbits before we get to the examples. First of all, the coefficient for x must be 1. So if I had something like this, x plus 3x plus 5 squared, I'm going to have to factor out that 3. So out comes the 3, and now I have x plus 5 over 3 squared. So that's going to be my horizontal component, and that's actually going to be a compression. All right. So let's go on to the next important tidbit. That's going to be the impact of a. We're influencing the y-coordinate. So when a is greater than 1, all my y's are going to be impacted. So if I had like a 3f, it's going to be x 3y. Okay. And if it's less than 1, it's going to be shrinking. We're going to compress the graph by a factor of 1 over a. Similarly with b, we're going to have the same thing, but again, I said it's counterintuitive. When b is less than 1, we're going to stretch it. And you played with your calculator in Algebra 1 when you had the parent function of a quadratic. Then you did 1/2 x squared, 1/5 x squared, and it just kept getting wider and wider and wider. And conversely, when you did it greater than 1, that little quadratic, that parent quadratic, got narrower and narrower and narrower. Just really grew really fast. So it's the same thing. So again, it's a little counterintuitive. So when we talk about horizontal, it's kind of horizontally shrinking. You may think of it as a vertical stretch, but there's an important impact because it's your x coordinate that's being impacted. It's going to be, so if I had a 3x or whatever, okay? The next tidbit is the order of transformations, and this is something we're going to experiment in class. I will intentionally have a few volunteers in class who will do these out of order, and we're going to compare graphs. So the first thing we're going to do is we're going to stretch or shrink, and that's going to be your A and your B right here. And then we're going to do our reflections, and that's going to be these signs right here, whether it's going to be across the X or it's going to be across the Y. Then the last thing we're going to do is we're going to do our translations. So let's go ahead and take a look at how we do this on an example. So here I have my first example, and this is going to be P of x is equal to 7 times 2 minus x plus 6. And this is the absolute value parent function. So the parent function is the absolute value one, okay? And right now I notice that this is not quite the way we wanted in our thing. So we're going to have to rewrite this. So I'm going to go ahead and flip this, and it's going to be negative x plus 2. And this has to be a positive 1. So I'm going to have this as 7 absolute value of negative 1 times x minus 2, close that parentheses, plus 6. Okay? My generic is going to be 7p negative 1 times x minus 2 plus 6. And what's going on here is this. We're going to have a vertical stretch, a factor of 7. And this is on your y coordinate. Okay? We're going to reflect it across the y-axis because we got this going on right here. So we're going to reflect across the y-axis. And then we're going to go ahead and do our translations. We got 2 of them. And we're going to translate right 2 up 6. All right? And this is what I'm going to be looking for right here. I'm going to look for the generic and then the description of what's happening. Our next example, here we have another function. This is going to be our even square root function. So the parent is going to be an even root. Okay, it's going to be square root. F of x is equal to square root of x. So let's go ahead and get this cleaned up. We want to write this as a generic function. So I'm going to go ahead, and this negative is going to go in the front right here. And I'm going to have 3x minus 4 and plus 5. All right. Now we see the problem right here. X does not have a leading coefficient of 1, so I'm going to have to factor that out. So here we go. Out comes the 3, and I have the x. There's my leading coefficient of 1. But this turns this into a 4/3. Okay? So this is going to be my final product that I'm looking for from a generic standpoint. So what happens here? Well, what we got is we have a horizontal shrink because this is affecting my x coordinate. So I have a horizontal shrink of a factor of 1/3. And this is on my x coordinates. Then I have reflecting across the x-axis, across x-axis, okay? And that's this guy right here, okay? Then we're going to have our translations, and I'll just go ahead and write them both at the same time. I'm going to go right 4/3, and we're going to go up 5. All right? So that's just a couple examples of what we're looking for. Again, we're keeping it fairly basic. The B's are what's going to cause problems, so make sure you do all homework problems in regarding to this topic.